All right, this is going to be AP Calculus, Lesson 3-2. Our title for today's lesson is Graphical Analysis. So we're talking about F increasing, F decreasing, and the critical values of F. So CV, we abbreviate. All right, we have our setup down. Our first category is reading F and F prime graphs. So let's go ahead and make our first graph. Let's just do a quadratic, a positive quadratic. What does that look like to everyone? Nope, that's positive linear. Yeah, there it is, positive quadratic. You guys got it. So it's a something that looks like this. I should draw this a little bit better. If it was more accurate, this should have gone out in this direction and out in this direction instead of going straight up.
Oh,
but
now I did straight up.
But I apologize. We should have made that better. So I want to call this thing, this is going to be the graph of, what do you think? If I'm, yep. And then the next one is going to be graph of F prime. And you guys did this, and I'm going to do this for the video as well. You said that this was a positive quadratic because it's a smiley face or it's a valley. If it's a peak or if it's a rainbow, however we want to call it, then it's a negative quadratic. So if this is a positive quadratic, when I take the derivative, what should I have?
A negative?
No, so negatives stay consistent throughout the equation. Unless you have something with a negative power to begin with.
Wait, what was the question?
So if I have a positive quadratic and I take the derivative, I have a what?
Oh, exponential?
Nope. Linear. We did this yesterday. Linear, and what about the linear? Is it positive or negative linear?
Positive.
Positive linear.
So the sign will stay. Yeah, that makes sense.
Yep, so let me go ahead and use my line tool.
My cuticles are so wish I was.
And we'll say something that looks like that.
Through the origin, Mr. Sindel?
Whatever. I went a little bit off, but you can do it straight through. It doesn't matter to me.
Because it was like off the page.
All right, so let's look at the 3 points that I care about. So I'm going to make them black. These 3 points.
Yeah, like if you had like a button.
Think it.
Yes. And just like green. Like, wouldn't that be so? But then like we could also.
All right, so far we're in review mode. This is all from yesterday.
Yeah.
So if I'm talking about, I have to figure out how I'm going to color code everything because I want to be consistent. So I'm going to say black is my heights. So heights.
What about us? We don't have color codes.
You can get some markers if you want.
I'm good.
So heights. If this is a graph of F, what represents heights? Heights is F, F prime, F double prime, maybe not a thing at all. Heights is just F. So all of these heights is going to be represented just by F. Or F is represented by the heights.
You're not saying the height of any particular point, you're just saying that like F means height?
So I'm saying, wait, say the question again, Kaylin?
So like when you say heights is F, like you're not saying the height of one of those points, right? Like you're just saying like all of those 3 points is just F.
Exactly. In general, not any one point in particular. I'm just saying all the heights can be represented with F. So then what are the slopes going to be?
F prime.
So I'll say slopes are going to be F prime. So you can think about maybe the slope over here looks about like that. Slope over here is about like that. Slope over here looks roughly like that. And then what is concavity?
F double prime.
I guess my last color here is green. We can still see this on the projector, right? Yeah.
Yeah, buddy.
On my screen it looks really light, almost like a yellow, but you guys see it as a very dark green.
I wait for that. It's a pretty green. I'm just kidding.
Concavity is F double prime. All right, and that would be anywhere in here. Concavity is going to be positive. Positive concavity because it's a valley, it's not a rainbow, it's not a mountain. All right, so if I'm looking at the graph of F prime, so what are heights going to be represented by now? F prime, yeah. So heights here.
Which is where you were yesterday.
Heights is now F prime. So what is slopes? What are slopes?
Double prime.
So slopes are F double prime. And what about Come on now. What about
We don't mess with jerks.
we don't mess with jerks.
Amen.
So concavity,
Oh.
that's going to be F triple. It's not that it doesn't exist. It exists, but we don't really care about it. F triple prime, we call this a jerk. And the reason for that is it's the acceleration of the, or it's not the acceleration, it's the change of the acceleration. So if that change in acceleration is really fast, you've been jerked, like if you've been jerked out of your seat. I am. So you got your blowing of your nose on camera. Yep.
Well, now they did because you brought it up. They're gonna like, rewind the video.
All right.
At least they know what it is.
And we don't care about jerks. We don't care about jerks in this class. All right, so, and can we make a note on the side? I don't think we made this note yesterday, but if I have a positive quadratic, a positive quadratic will always turn into, when I take the derivative, the arrow, I'm assuming that means derivative, that will turn into a positive linear. We already stated that. I'm writing it down to make it explicit. All right. So when I have this case, my f double prime, no matter what's going to happen, it'll either be 0 or it's going to be positive because I've stayed positive. We don't need to write that down, but we're good. Okay, so this is just review. We're all good. We shake our heads vigorously up and down. Yes, Mr. Snell, we understand this. Last night's homework was clear.
Yes, Mr. Snell, we understand last night's homework was clear.
Yes.
That's what I want to
So the
hear.
reason why is because we don't mess with jerks. That's why. That. Right.
For
the homework, like that's why some of them were blank because it was like at triple prime.
That's not the reason. So I can go into that a little bit more after the lesson.
Also, it's because
The reason is we can't go backwards. We can only go forwards with our derivatives. We can't take the antiderivative, not yet at least.
Yeah. So, but then weren't there also?
yeah.
Wouldn't there also be f triple prime?
No, because like, you can actually look at this. Like, do you see how it says the graph of f prime? So
Yeah.
now heights are f prime. That's why we cross out this one.
I get it. But like, so we never had a graph of f double prime.
No, we never did.
Oh, okay, that makes sense.
So let's talk about some increasing and decreasing behavior. So let's talk about when a function is increasing. So we'll say function increasing. What does that mean? So let's abbreviate it first of all. So I don't want to write out this whole thing. So our function is usually f. Sometimes it might be g. Sometimes it might be m. I don't know, some letter. But f is nice because it actually stands for function. F starts with the f sound. And increasing, inc, just like we have for the title of the notes. So what does that mean? If the function is increasing, that means, and this is probably one of the most important things we're taking away today. Maybe I should have given myself some room to start this. But that means that the derivative, f prime, is what? Is it positive, negative, 0? If I'm increasing,
It's positive.
Positive.
it's positive. And then we have to do the opposite. So give yourself some room. I kind of ran out of room because the logo's in the way. It would have been nice to write over that. But right here, I need to say that this is uphill. So if I'm going from left to right, I'm going uphill. Always assume left to right. Because in our culture, we always read left to right. If you're in a different culture, different language, you might read right to left and it might be different. That's a weird tangent. Okay, coming back. Function.
Anyway.
Function decreasing. That's obviously going to be represented by what? F decreasing, DEC. And again, I'm running out of room, so I'm going to say my equal sign down here, but you would want to have yours all in the same line if you could. So what do we know about our f prime? Our derivative is?
Downhill.
It's downhill, yep. So that's going to be the third thing. But what do I know about the value of f prime in terms of
Less than 0.
less than 0? Another way of saying that is just with an n.
Downhill.
Negative.
Negative, there it is. So that's downhill.
So would you rather have us say negative and positive than like f is less than 0?
Either way is fine. I want you to know both though. Those are those are interchangeable. All right, so let's look at those same graphs again. So I could copy and paste, but I'm going to try to make my graphs better this time. So come here. I need a line. Let's go ahead and get ready to make those same two graphs.
Wait, so since we wrote downhill, like would downhill be right to left?
No, it's always left to right for all of these. Downhill, left to right.
Oh, I get it. Okay. Well, let's just forget it.
All right, so let's try to draw a better quadratic function that doesn't. It still has. I don't want to have a vertical tangent at all. So that's better. Oh, but now it looks horrible. We got this. We got this. Okay. It looks okay. And of course, when I take the derivative of that, I get what?
Linear.
Linear. Oh, I want a blue line. We'll say that goes right through the origin. So I need to analyze where my function is increasing, where it's decreasing. And I'm using these as hints. What's going on? Okay, so again, let's label these. This is the graph of f. And therefore the one on the right is the graph of f prime. I usually try to put this in a box to make it stand out more. Graph of f prime. One thing that I haven't really pointed out before, and I should have, and I'll point it out now, is where is the slope 0 on this quadratic?
The bottom.
The bottom? What x coordinate is it?
No, 0.
0.
At x equals 0, approximately, if I drew this better, yes, it should be at 0. And notice where the height is 0 on this graph.
0.
Yeah, those two are the same thing, they match up.
F prime.
Those are both f prime. The slope is 0 here because the height over here is 0. These are interchangeable in terms of what they mean. All right, let's talk about where f is increasing. So the question becomes, we'll just write it down here. The question is this: where is f increasing? You need to tell me. And where is f decreasing? F decreasing.
Just okay.
It looks like x, DCC, so decreasing. So what do we know? Where is this graph uphill? Where is the slope, this f prime positive? Where is the slope greater than 0?
The right hand side.
Yeah.
The first and fourth quadrant or the right hand side? Yeah, so you want to think about this in terms of the x. So you want to say for x values greater than 0. And maybe.
But isn't it also kind of going uphill still, like the negative?
Say that again?
Like, aren't there, like, say at like x equals -1, isn't it still going uphill?
You're saying it's going uphill right here?
Oh, never mind. I was thinking of y.
Oh, okay. Yeah, so in terms of
Okay.
x, we're always thinking about x, so maybe we want to write that in our notes. Always asked about x values, so x values. So f is decreasing for what x values? What about exactly at 0? Is it decreasing exactly at 0?
No. That's where the slope equals 0.
Yeah, and it has to be greater than 0. So it can't be exactly 0. So I'm going to say it can't be equal to 0. And this is interval notation for those of us that want to remember the name of this. And it goes all the way to, where does it stop decreasing?
You don't have that point labeled.
Exactly, yeah.
I like
Assume.
maybe x.
Infinity.
Infinity. It goes on and on forever. It keeps increasing towards infinity.
Oh.
It goes on and on forever.
Okay, that makes sense.
And infinity always has this parentheses. It's never a square bracket. It can never equal infinity. That doesn't make sense. And then in inequality notation, as an inequality, you can say x is, where does x live? Where f,
Greater than 0?
yeah, it's greater than 0. X greater than 0. And then do the same thing for decreasing. Where is it decreasing, girls?
negative infinity?
X less than 0, and yet negative infinity, all the way to 0, parenthesis or square bracket. Square bracket like that?
No, parentheses.
Why is it a
Wait,
parenthesis?
why is the infinity in the x?
But it's limited, isn't it?
So okay, let me address a bunch of questions at first. First of all, this is a parenthesis and not a square bracket because it can't be equal to 0. At exactly 0, it's f prime is equal to 0, and we need f prime is less than 0. And the reason that I did negative infinity and then 0 is because I always write my less than, my smaller value on the left, and my greater value on the right for interval notation. Negative infinity is quite a bit smaller, or I shouldn't say smaller. It's definitely, we'll say the more negative values on the left and the more positive values on the right. That's a better way of saying it. Because negative infinity is still a big number, it's just a big number in the negative direction. All right, nod our heads vigorously if we're ready to move on.
I think so.
Wait, we
Alright.
haven't done graph of f prime. Oh, I thought you meant move on slides. Sorry.
I was thinking about moving on to slides because so this one we can say the same thing though. I mean this has an answer where this question is answered by this answer. Where is f increasing? If I'm looking at a graph of f prime, where is f increasing? You say 0 to infinity, but I'm still asking the same question. F increasing, not f prime increasing. F increasing means what? This guy right
Oh,
here.
it's continuing. It's forever.
Uphill.
Where is f prime greater than 0 on this graph?
It's like the whole graph.
No, because this is a graph of f prime. So am I looking at slopes or heights?
The right
Height.
side.
Positive coordinate.
So Joy has it. I'm looking at heights here. Heights represent f prime. Where are the heights positive on this graph?
Oh.
Anywhere above 0.
So I'm looking at, in terms of x values, right?
Oh.
Where,
Then
what x values have a height that's positive?
1, 2, 3, 4, infinity.
The same answer down here. What heights, where is f prime negative? Same question here. Where is f prime negative on the graph of f prime now?
Less than 0.
Less than 0. So these two graphs gives you the same answer.
So should we write that? They transfer. The answers transfer over.
Oh.
Sure, if you would like, yeah.
Yeah.
The
Because it looks weird if we don't.
What time are we leaving? Like, what time
11.
do we get to-
Do they go over that in the morning meeting? They're usually very big.
Yeah, morning meeting stated that after third period technically, so 11:02. You guys can get out of here at 11 though.
But we're supposed to leave at 11.
Oh, is that true?
Yeah.
Okay, we'll try to get you guys out a little bit early. Just for my class, that doesn't apply to other classes.
What does that word say? Same aim?
Same answer.
Oh.
Yeah, I could improve my handwriting there. So I'm still using my same analysis to get the same answer. So I can give you either the graph of f or the graph of f prime and ask you where is f increasing and where is f decreasing.
So they always transfer over. Always.
Always, are you asking like if I gave you f double prime, would that transfer all the way to f?
Yeah.
We will take a look at that.
And then, but then also, is it true that f and f prime will always transfer over that way?
F prime and f, yes, this will always happen. And I needed to look at some more examples. For just this lesson, I think we're only going to stick with f prime and f. All right, are we ready for the next slide? All right, so here we go.
Is this our last one?
Yes, and then I'm going to do some examples. So we might have two slides, one for the notes and then one for examples.
I'm just going to keep moving on.
I'm just trying to
Wait,
Okay.
how much room do you think we need for this slide?
This slide is going to be half a page or less, probably less. I would say a quarter of a page. Our last thing in our title was critical values. We know where f is increasing and where f is decreasing, so now we're going to do our critical values.
So I can move on my computer.
Okay.
My handwriting is starting to get sloppy. I'll take my time. Critical values.
Are we all gonna get
I think all of us, just in case someone were to have.
or like somebody's class?
So our abbreviation, so a functions, oh, here we go, functions, critical values, we represent this with the symbols, the function CV, critical values. There are only two things where there can be a critical value, and here they are. The first thing. This can be equal to, I'm still equaling these. So the first thing is it can equal where f prime is equal to 0. So maybe equals is the bad way of notating it. I'll just leave it like this. And the second thing where you have critical values is where f prime does not exist. Most people will forget about the second one because it's hardly used, but I'll give you a sharp corner for our example so we get to practice this. So anytime this happens, you have found a critical point. And I'm only talking about the derivative. So if I have something where the double derivative doesn't exist, but you don't know anything about f prime, you can't tell if it's a critical point. You can't go backwards. It's only f prime.
There are going to be more questions like, what must be a critical component?
Yep,
and what
exactly.
might be? Oh.
Yep. All right, so here we go. Let's do one graph. I'm going to do it over here so I can conserve space a little bit.
We're only doing one graph on this side?
Only one graph, and it's going to be kind of a crazy one. So it's going to look like a sine wave at first, so let's go, don't want to go too steep here. Let's go,
What the?
I'm trying, guys. It's really hard.
I thought it was really good until then.
Let's see if I can continue.
It's really hard.
Right there, and then we'll just say boing right there. Okay.
I ran out of room for my shirt.
Okay. So let's label some points. So this is, first of all, I'm telling you that this is the graph of f. Not f prime. By the way, critical values are really easy to see too on a graph of f prime because, I'm going to come back to this slide really quick, it's where f prime equals 0. Where is f prime equal to 0 on this graph?
Nowhere.
Where is the height 0?
0.
0, right. You're just looking for a height of 0, where it crosses the x-axis. Pretty easy to see. But when I'm looking at a graph of f, it's a little bit harder. All right, so critical values. Critical value there, and where's our last critical value?
The sharp edge.
Yeah, that sharp edge, sharp corner. Okay, so we'll label on the graph why these are critical values. So this is where f prime equals 0. This is a critical value because what? F prime.
Equals 0.
Yep. And what about this one? F prime.
0.
Does not exist.
Ah, yeah, it's
DNE.
DNE. It's one or the other.
So most of the time it's just going to be because f prime equals 0.
I'm going to mix it up, so just be prepared for both. Usually it is f prime equals 0 on the AP test, but sometimes they throw in one of these too. Okay, so now why do we care about critical values? And it's because this is where max and min happens. Look at this. We had a minimum value down here, a maximum value up here, a relative max, a relative min. We don't know if it's the absolute max or absolute min, but we care about critical values because it gives us max and min. So we'll say that this guy was our min, this guy was our max,
And another min?
you can say it's we haven't formally defined this, I'll go over this later, but you can say this is a relative min. But it is a type of minimum, you're right.
Okay. Do we have to write that down, or do you just want to?
Sure, go ahead and write it down. It's not that much.
take a nap. Oh, yeah, mine
So how do I tell if it's a minimum or a maximum if I just look at the slopes? So let's write this on the sidebar over here if you have some room. So when f prime goes from a negative into a positive, what is that going to be? Is that going to be a minimum or a maximum? Think about this and don't answer right away. Please wait 10 seconds before answering. If I have f prime, the derivative, and I change from a negative to a positive, am I at a minimum or am I at a maximum? And then obviously the question becomes, the other one, if I go from a positive to a negative for f prime, is that a minimum or a maximum? Okay, you've had 10 seconds to think about this. Let me see those hands, quiet raised hands. Is this a minimum or a maximum? Who knows or thinks they know the answer? If I change from a negative to a positive.
Do I need to?
Only Joy has an idea?
I
Isabel?
guess, but you're gonna tell me it's wrong.
Yeah, I'm just throwing out a guess.
All right, I'll go with Joy.
Maximum?
So you're going to say maximum?
It's going from left to
All right, agree or disagree?
That's what I was gonna guess too, because it's like
Agree.
getting bigger.
All right, so that is actually incorrect. So think about this. We had a minimum over here. What is this point right here? The derivative is
Negative.
Oh, and it's going to positive.
negative,
Minimum.
and we have a derivative on the right-hand side. This derivative is positive. So I went from a negative to a positive. Therefore, this is not a max, but a min.
I'm not gonna. Can I write it in my notes section?
Yeah, like on the sidebar?
Yeah.
Yeah, that's fine. And then if I go from a positive to a negative, that is the opposite, which is a
Max.
max.
Max. Max.
And where do max and mins happen?
It's a lipstick, but
At critical points. I don't know.
Yep, exactly. Max and min happen at CVs. We'll say F critical values, FCVs. All right, and I promised that I was going to do an example for us. So here we go. You guys are going to have to solve this one now that we have understanding of all the notes. So my last example, I'm going to give us two graphs of F, graph of F prime, and I'm going to tell you these are not going to be related. I'm going to actually do just two graphs of F prime to see if we can get it.
You know what? I think the best people are the ones who just would for.
I don't think it's a competition.
I think we're all equally good.
I think we should love each other.
All right, so copy down these two graphs. Oh, what the heck?
Yeah, man, I'm gonna have to do my summary. What should I do?
It's just gonna be like a half page. Just go for it. Build up. You know? There's I bet you tomorrow's notes are gonna be 2 pages as well, and it'll catch us back up.
They better be. Just
No, for mine's already
Make
mixed
longer.
up. Peas.
But basically, you're not gonna take a point if our notes are 2 pages
Nope.
so that they're not on the
Nope, that's fine.
As long as
they're
we have
next to
them.
each other.
No.
Exactly.
Okay.
Graph of F prime, and this one is also going to be a graph of F prime on the right. Two different graphs, they're not the same.
Wait, is this like a new section on the side?
example.
This is
Oh.
an example.
Okay.
I can
You
label
already
this.
said that, Kale.
I'm sorry.
And the views towards
Kale.
All right, another graph of F prime.
Car, stop! Harley, why would you hit me?
I used to do that. Oh.
All right, I need to know where are the FCVs? Where are the critical values? Where are these critical values? Oh, I should probably
They're in our heads.
go ahead and write it down.
Ow.
You can always erase it. Go ahead and make those points on your graph. Actually, write on your graph. Where are those critical values? I'll give us another 10 seconds to try to figure them out.
She's my best friend.
Where are the critical values on these graphs?
No
What'd she
way.
say? What'd she say?
Look, don't yell, Rosalie.
All right, here we go. So our critical values, I'm going to do this in a different color to make this stand out more. We had 1, 2, and 3 critical values. I'm going to label them A, B, and C.
Wait, I don't get B or C or A.
Remember, this is the graph of f prime, so where is f prime 0? Or it does not exist. F prime is 0 means I'm looking for the height.
Oh.
Where is the height 0? It's where it crosses the x-axis.
Dang, I have to erase.
So the critical values are at x equals A, x equals B, and x equals C. Those are all of our critical
Oh,
values.
so that's when they cross the x out. Okay.
So I'll make a note here. This is where f prime equals 0 or f prime dne.
None of these are DNE, right?
None of those were dne. All of these were 0.
Wait, I haven't done the next one, so give me a second.
All right, I'll give us another 10 seconds. Figure out where the critical values are for our next graph.
Wait, so for this one, do we just write all equal 0?
What do you mean they all equal 0? Like the height equals 0?
The critical.
Sure. I'm guessing you want to change it to this, so it's where f prime equals 0 because none of them do not exist like this.
Okay. Yeah, because I was like, where doesn't it exist?
I was just trying to give us the definition over and over again.
Okay.
Maybe we should just write that definition on the sidebar. FCV, those are, oh, that's a CW. FCV, that happens where?
0 and D.
For what type of, is it F prime, F double prime?
F prime.
F prime equals 0 or F prime DNE.
Mr. Sindel, can I go to a meeting?
Yes. This is going to be the end of our notes right here, and then you're going to do the summary. All right. You have 5 more seconds for FCV. I'm looking at my clock.
I think I have.
I don't know. Just the
Oh.
points where.
And here they go.
X-axis.
So I'm going to call this x coordinate A. Maybe I should do this in a different color. This x coordinate is going to be called A because that's the first x value, and this x coordinate is going to be B.
I got it.
So FCV is where x equals A and B. Because in this case we had one of them, so this guy was where f prime DNE. Why is it a DNE there?
Because there's a hole
Nothing.
or a gap. I
It's
don't know.
what's that? It's not defined.
It's not defined, yeah. That's a good point. It's not defined, so it can't exist. You guys said it was a hole. It's really a gap, I guess.
I'm still confused the difference between a hole and a gap.
So a hole looks like
And
that,
then the line continues.
and a gap looks like that.
Oh, okay.
Although I don't really care too much, and I don't think the AP graders care either. They want to know the main category, which is what? Starts with it?
Non-differentiable.
Discontinuity.
Discontinuity,
Dang
exactly.
it. Wait, but differentiable applies continuity, so technically I would be right.
You're right that it's not differentiable,
Yeah.
but the reasoning is because it's not continuous.
Yeah.
Yeah, or it's discontinuous. And B, that's where f prime equals 0. Yeah. So that's an FCV. That was an FCV as well.
Is that it?
And that's all we have.
Wait, can we say goodbye?
Bye.
All right, say goodbye to the video.
Don't mess
Peace
with
out.
jerks, okay?
Don't mess with jerks.